Welcome back to The Explainer. Today, we're bringing some serious energy to the construction site. We are going to explore the beautiful, systematic rhythm of building a house's foundation, quite literally from the ground up. You know, every great structure has a beat, a strict sequence that absolutely must be followed perfectly.
Okay, let's dive into this. If you want to lay a base that will stand the test of time, you can't just go out there and start digging randomly. A foundation is hands down the single most vital component of any building project. Why? Because it literally carries the weight of everything above it. So, how exactly do we get it right?
Well, there's a golden rule in construction that goes a bit like a rhythm. Dig it deep, build it strong, follow the steps, and you can't go wrong. It's all about this sequential flow. Think about it. If you miss a beat, your walls might crack and your floors might shift. So let's map out the exact steps to keep our construction in perfect harmony.
Here's the first half of our construction rhythm. 1. Site selection, finding that stable soil. 2. Excavation, carving out the earth. 3. Anti-termite treatment, creating a hardcore chemical shield. And 4. Soil compaction, pressing the earth down tight. That right there is your groundwork and protection phase.
And this brilliantly illustrates where the structure truly takes shape in the second half of our sequence. 5. Wooden formwork, setting the mold. 6. Reinforcement steel, tying the bones together. 7. Concrete pouring, casting the solid stone. And 8. The plinth beam, crowning the base. 8 precise steps to an absolutely perfect foundation.
But hey, before we break ground, we need our instruments, right? Think of this as our rapid-fire checklist. We need the shovel and pickaxe for the hard earth, the trowel and spirit level for absolute, pinpoint precision, measuring tape, string, and pegs to map out our lines, a wheelbarrow for the heavy lifting, wooden planks to hold the shape, and, of course, the concrete mixer to blend up our heavy stone.
Let's start the first verse. Section 1. The groundwork. Site and excavation.
So once we've confirmed the soil isn't just loose sand and the water table isn't sitting too high, we mark our exact layout. We place our pegs, run our string lines tight, and drop chalk powder to show the crew exactly where to dig. Then we excavate. Now, the depth of those trenches completely depends on the soil type and the load of the building. But let's actually slow down the rhythm for just a second to understand the engineering why behind the dig. Look at this equation. P over A, that represents our vertical compression load divided by the area of the footing. M over S represents the tension from overturning moments, think wind or seismic forces, divided by the section modulus, which is really just the geometric strength of the footing shape. For a foundation to be stable, P over A absolutely must be greater than M over S. Why does that matter? Because the interface between your concrete footing and the soil below can only handle compression. Soil cannot handle tension at all. It just pulls apart.
So, the entire job of this footing is to spread that vertical load safely and evenly across the earth below. If we distribute the pressure uniformly, the whole home settles evenly. If we don't, well, we get differential settlement, which is literally a structural nightmare.
Moving on to verse 2, section 2, the protectors, dealing with termites and compaction.
Remember the mantra, dig it deep, build it strong, follow the steps, and you can't go wrong. We've dug our trenches, but before a single drop of concrete goes in, we have to guard our base from two invisible enemies, the settling of loose earth and the hungry jaws of termites. For a reinforced cement concrete, or RCC foundation, our anti-termite treatment has to reach exactly 500 millimeters below the ground level. We are building a chemical barrier so deep that pests simply cannot cross it.
So the crucial point is the dosage. You can't just go in there, spray, and pray. For the vertical soil directly in contact with the substructure, we must inject exactly 7.5 liters of a chemical, like Imidacloprid, per square meter. We literally rod the soil, pushing the treatment deep into the earth to repel pests for decades to come.
Next up, we tamp it down. The soil has to be moist, and we use a heavy mechanical plate compactor to squeeze those loose dirt particles tightly together. We are literally forcing the air out of the earth, increasing its density so our future concrete has a rock-solid, completely unyielding bed to rest upon. Section 3. The skeleton, covering formwork and rebar.
Now, concrete is incredible at handling compression, right? But it's famously terrible at tension. So we erect vertical wooden planks along the inner perimeter to act as a mold, and we bring in the steel rebar to act as the skeleton that'll handle those stretching, bending loads. There is a very strict rhythm to placing the steel. First, it must be designed by a structural engineer. No guessing here.
Then, we use these little plastic or metal stands called bar chairs to lift the rebar off the ground. This guarantees there is proper spacing so the liquid concrete can flow completely under and around the steel, giving it the perfect protective cover so it doesn't rust.
Section 4. The solid stone. The concrete pour.
So we mix our concrete, usually a minimum of M20 grade for residential foundations, and we begin to fill our precisely measured wooden molds. Now, what's really interesting here is the pouring technique itself. It is highly critical. You don't just dump all the concrete in at once. No way. You pour it in continuous lifts of 18 to 24 inches. This methodical, layered approach prevents the formwork from literally bursting open under the massive pressure, and it ensures there are zero weak joints or cold spots in the footing.
And as we pour, we tamp. Using a tamping rod, we vigorously poke and vibrate the wet concrete. This squeezes out all the trapped air voids that could otherwise leave these fragile, honeycomb-like weaknesses inside our solid stone base. We trowel the top smooth and, boom, our footing is cast.
But wait, the job isn't done when the pour stops. Remember this number, 7 days. That is the absolute minimum amount of time you must cure that concrete with water. And curing isn't about drying. Actually, it's a chemical reaction. Keeping it completely wet allows the concrete to reach its true intended durability. If you skip the cure, you completely ruin the pour.
Section 5. The crown. The plinth beam level.
The plinth beam is this continuous horizontal beam built about 450 to 600 millimeters above ground level. Think of it as a belt, tightly tying the isolated footings and foundation walls into one unified, rigid ring around the perimeter. Before we pour it, the site engineer goes through a rapid-fire checklist. Verify the line, level, and dimensions against the blueprint. Check the lap length where the steel rods overlap. Ensure those clear cover blocks are perfectly placed. And crucially, confirm that any embedded pipes or sleeves for plumbing are set before the concrete is poured. You do not want to be drilling through this later.
Let's move on and see how this builds out the rest of the structure. Now, don't confuse the plinth beam with a tie beam. The plinth beam sits right down at the base level. Its main job is to evenly distribute the heavy vertical load of the walls straight down to the foundation, preventing that nasty differential settlement we talked about. A tie beam, on the other hand, sits much higher up, like at the roof or lintel level. Its job is to connect columns together to stop them from buckling outward under lateral forces, like heavy wind. Dig it deep, build it strong, follow the steps, and you can't go wrong. We've successfully selected our site, excavated, treated for pests, compacted the earth, tied our steel, poured our concrete, and capped the whole thing off with a continuous plinth beam. You now have a rock-solid base that is going to last for generations. But you know, a solid base is really just the beginning. It ensures the house stands, but what dynamic, lateral, and vertical forces will your superstructure face next once you start building up towards the sky? Well, that is a fascinating question, and one I highly encourage you to think about until next time.